The Fluke electrical tester offers 3 methods for detecting alternating current or direct current voltage. Firstly, it uses a light indicator. Secondly, it employs an audible sound. And thirdly, it provides a vibration alert. This tester includes a ground fault circuit interrupter, GFCI, trip function allowing the user to test GFCI outlets and circuits. A continuity beeper is integrated into the design of the Fluke electrical tester, providing an audible indication of circuit continuity. The tester features a built-in flashlight for improved visibility in dimly lit environments. The T+PRO electrical tester model includes a rotary field indicator specifically designed for troubleshooting 3-phase electrical systems. This feature helps electricians identify phase rotation and diagnose potential issues within 3-phase circuits. The T+PRO electrical tester offers resistance measurement capabilities with a range up to 9.99 k-ohms. This allows users to measure the resistance of various electrical components and circuits. A backlit liquid crystal display (LCD) is incorporated into the design of the T+PRO electrical tester for enhanced visibility in low light conditions. The backlight improves the readability of the display, making it easier to view measurements and readings. This meter is rated as Category 3. Electrical safety is paramount when working with electrical circuits and equipment. Understanding the safety ratings of test equipment is crucial for preventing electrical hazards and ensuring user safety. Category ratings, defined by standards such as IEC 61010.31, classify test equipment based on their ability to withstand transient overvoltages in different electrical environments. These ratings help users select the appropriate test equipment for the specific application and voltage levels encountered. Category 1, Cat 1, measurement category is for measurements performed on circuits not directly connected to mains. Examples are circuits protected to the mains by a transformer or electronically supplied equipment. Category 2, Cat 2, measurement category is for measurements performed on circuits directly connected to the electrical mains at utilization points such as outlet sockets and fixed wiring. Category 3, CAT3, measurement category is for measurements performed in building installations at the distribution level. Examples are measurements on distribution boards, circuit breakers, wiring, including cables, bus bars, junction boxes, switches, socket outlets in the fixed installation, and equipment for industrial use and some household appliances. Category 4, CAT4, measurement category is for measurements performed at the origin of the installation. Examples are electricity meters and measurements on primary overcurrent protection devices and ripple control units. When using electrical test equipment, it is important to adhere to safety precautions to minimize the risk of electrical shock, arc flash, and other hazards. Firstly, always inspect test equipment before use to ensure that it is in good working condition. Check for any signs of damage, such as cracked housings, frayed leads, or loose connections. Do not use equipment that is damaged or malfunctioning. Secondly, use test equipment that is properly rated for the voltage and current levels of the circuits being tested. Ensure that the equipment meets the appropriate safety standards and is suitable for the intended application. Thirdly, wear appropriate personal protective equipment, PPE, such as insulated gloves, safety glasses, and flame-resistant clothing when working with electrical circuits. This will help to protect against electrical shock, arc flash, and other potential hazards. Fourthly, disconnect power to the circuit before making any measurements or performing any tests. Use a voltage tester to verify that the circuit is energized before proceeding. Fifthly, avoid working alone when performing electrical work. Have a qualified person present who can provide assistance in case of an emergency. Sixthly, never work in wet or damp conditions, as this increases the risk of electrical shock. Ensure that the work area is dry and free from moisture. Seventhly, follow the manufacturer's instructions and recommendations for the safe use of test equipment. Read and understand the equipment's operating manual before using it. Eighthly, be aware of the potential hazards associated with electrical work and take steps to minimize the risks. Use caution and common sense when working with electrical circuits and equipment. Ninthly, regularly inspect and maintain test equipment to ensure that it remains in good working condition. Replace any damaged or worn components promptly. Tenthly, properly store test equipment when not in use to protect it from damage and prolong its lifespan. Keep equipment in a clean, dry environment, away from extreme temperatures and humidity. Understanding electrical safety principles and following safety precautions are essential for preventing electrical accidents and ensuring a safe working environment. By adhering to these guidelines, electricians and other electrical workers can minimize the risks associated with electrical work and protect themselves and others from harm. The resistance measurement function allows users to measure the resistance of various electrical components and circuits. Resistance is a measure of the opposition to the flow of electric current in a circuit. It is measured in ohms, symbolized by the Greek letter omega. Resistors are electrical components designed to provide a specific amount of resistance in a circuit. They are used to limit current flow, divide voltage, and perform various other functions. The resistance of a resistor is determined by its physical characteristics, such as its material, length, and cross-sectional area. The resistance of a conductor is affected by its temperature. As the temperature of a conductor increases, its resistance also increases. This is because the increased thermal energy causes the atoms in the conductor to vibrate more vigorously, which hinders the flow of electrons. The resistance of an insulator is very high, which means that it does not allow current to flow easily. Insulators are used to prevent current from flowing where it is not wanted, such as in the insulation of wires and cables. Ohm's law describes the relationship between voltage, current, and resistance in a circuit. It states that the voltage across a resistor is equal to the current flowing through the resistor multiplied by the resistance. The rotary field indicator is a valuable tool for troubleshooting three-phase electrical systems. Three-phase power is a type of alternating current AC electrical power that uses three alternating currents, each 120 electrical degrees apart. It is commonly used in industrial and commercial applications because it is more efficient than single-phase power. The rotary field indicator measures the direction of rotation of the magnetic field in a three-phase system. This information can be used to determine whether the phases are connected correctly and whether the motor is rotating in the correct direction. If the phases are not connected correctly, the motor may not start or may run in the wrong direction. The rotary field indicator can also be used to identify open phases or phase imbalances in a three-phase system. Open phases occur when one of the three phases is disconnected, while phase imbalances occur when the voltages or currents in the three phases are not equal. Open phases and phase imbalances can cause motors to overheat and fail. There are two main types of rotary field indicators: inductive and capacitive. Inductive rotary field indicators use magnetic induction to detect the direction of rotation of the magnetic field. They are generally more accurate than capacitive rotary field indicators, but they can be affected by external magnetic fields. Capacitive rotary field indicators use capacitive coupling to detect the direction of rotation of the magnetic field. They are less accurate than inductive rotary field indicators, but they are not affected by external magnetic fields. To use a rotary field indicator, connect the three leads of the indicator to the three phases of the three-phase system. The indicator will then display the direction of rotation of the magnetic field. If the indicator shows that the phases are connected correctly, the motor should run in the correct direction. If the indicator shows that the phases are not connected correctly, the phases must be reconnected in the correct order. The LCD provides a clear and easy-to-read display of measurements and readings. The liquid crystal display is a type of flat panel display that uses liquid crystals to create an image. LCD are commonly used in a wide variety of electronic devices, including televisions, computer monitors, mobile phones, and digital watches. LCD work by using an electric field to control the orientation of liquid crystals. The liquid crystals are sandwiched between two transparent electrodes. When an electric field is applied to the liquid crystals, they align themselves in a specific direction. This alignment controls the amount of light that can pass through the liquid crystals. The amount of light that passes through the liquid crystals determines the brightness of the pixel. LCD are available in a variety of resolutions and sizes. The resolution of an LCD is the number of pixels that it has. The higher the resolution, the more detailed the image will be. The size of an LCD is the diagonal distance from one corner of the screen to the opposite corner. LCD offer several advantages over other types of displays. They are thin, lightweight, and energy efficient. They also produce a sharp, clear image. LCD also have some disadvantages. They can be more expensive than other types of displays, and they can have a limited viewing angle. A backlit LCD is an LCD that has a light source behind it. The light source illuminates the liquid crystals, making the image brighter and easier to see. Backlit LCD are commonly used in devices that are used in low light conditions, such as mobile phones and digital cameras. The Fluke electrical tester, particularly the T+PRO model, offers a range of features designed to enhance safety and efficiency for electricians and other electrical workers. Its multiple voltage detection methods, GFCI trip function, continuity beeper, built-in flashlight, rotary field indicator, resistance measurement capabilities, and backlit LCD contribute to a versatile and reliable tool for various electrical testing and troubleshooting applications.